Hi everyone again. So I want to continue on the lesson review number 1. So I like to do another question for you. So here again, based on bed mass, I want to do yes, this one first and this one next and this one 3. I want to do that. So again, I start with equal and I just say okay, I want to finish the bracket first. So what is this common denominator between 3 and 9? So least common denominator between 3 and 9 is just 9. Okay, so I don't change 3 to 9 because I like it. No, that must be mathematically, logically correct. So I multiple the bottom with 3, and so I multiple top as well because I don't want to change my fraction. Okay, so it is 3 multiple 3 and 2 multiple 3 as well, okay, plus 5 over 9 multiplication multiple, okay, what is least common denominator between 4 and 12? Yes, it's 12. So it is 3 over 12 minus 5 over 12. Yes, so what did I do here? I multiple top and bottom. I multiple top and bottom with 3. So here is 1 multiple 3 and 4 multiple 3. Why? Because I wanted to change denominator to 12. And I have to multiply top and bottom with the same number. Otherwise, I am changing my fraction. I want to emphasize here, maybe it seems easy and funny for you, but sometimes I see when a student are stressed and they are in rush, they make mistake. So they change denominator 3 to 9 because they like it, because they need it. No, that's wrong. You have to multiply top and bottom with something. Okay, so here it is 6 over 9 plus 5 over 9. My handwriting, yes, it's awful, I know. So here is 3 over 12 minus 5 over 12. Oops. So okay, so it's 11 over 9 multiple minus 2 over 12. Okay, so separated, right? Okay, again, as I said, always when you are doing multiplication top, multiplication bottom, see, you are doing 11 multiple minus 2 divided by 9 multiple 12. Before doing multiplication, is simplify this and this. So it is minus 1 and 6. Okay, so it's minus 11 over 54. Okay, so minus 11 over 54. I cannot simplify further. Okay, so I stop here. Okay, so this question here, another question, I just added these questions because I believe you need more experience, so just more practice here. Okay, so here I need to do this one first and then this one next and then this one 3. Okay, so equal again, so equal, I use equal for each line. So equal 9 minus 3 multiple 3 plus 1, which is 9. Yes, I changed to my multiplication and I flip it. So it is 9 minus 9 plus 1, which is 0 plus 1, and which is 1. This is the answer. Okay? Okay, good. So now the next question is here. The next question is here. Oh my god, so it's a large thing, but doesn't matter, I can do it. Okay, so I need to do the bracket first. The bracket, inside the bracket, which is this one, I have several operations. Okay, so I need to do again bracket first. I don't have bracket inside. Okay, exponential, yes, so I need to do this one first, and then this one next because I want to finish that. Okay, and then these 3 and then these 4, okay, and then these 5 and then these 6 and then these 7 and then these 8. Okay, I can do several in the same line and doesn't matter. For example, the first one, if I do 4D, no harm done. Okay, so 4D, no harm done, doesn't matter. Okay, so minus 2 multiple 4 squared divided by 4, okay, Yes, again multiple 1 over 2, again multiple 2 plus 9. Okay, so it is 40 minus 2 multiple 4, because I can cancel one of them here, so it's 4 power 2 divided by 4, which is 16 divided by 4, which is 4, right? So I just cancel one of the 4 with each other. So, and then I continue, so it's 2 multiple that plus that. Okay, so which is, I can simplify again, so I can simplify this and that, so it is 40 minus 8 plus 9, which is 32 plus 9, which is 41. 41 is the answer. Okay, so you need to keep in your mind that bracket is first, exponential is next. If I have bracket inside the bracket, again I have to continue with BEDMAS again. Okay, inside the bracket again I have to continue with BEDMAS, and then division, multiplication at the same level, addition, subtraction at the same level, just from left to right. But doesn't matter. For example, here I know this must be part 3, but it's okay if I do it 40 and just keep it beside, because I don't mix them. Okay, so means you are doing several of them in one line. It's okay. Okay, and I don't need to do one line for each operation. I don't have room for that. I don't have a space. I don't have time. Okay, so how about here? How about this question? Okay. So I have radical. Okay, so radical is like exponent. Radical is like exponent power half. If I have radical x, that's x power 1 over 2. That's x power, so x power half. Okay, that's x power here, half, 1 over 2. Okay, so that's like exponent. But under the radical is like bracket, so I have to finish that first. Okay, so I have to do that first, and then next, and then 3, and then 4. Okay, and then 5, sorry, and then this here 5, right? I finish that here 6, yes, and then I do 7, and then I do 8. Okay, I can do, just for example, just in one line I can do several of them. Okay, so 100 radical 404 minus 4 plus radical 445 minus 4. Okay, so it is 100 radical 400 plus radical 441 equal 100 multiple 20 plus 21. So am I right here? So let me see my, okay, so here, so okay, do I have, okay, yes, so that, yes, 21. Okay, so that's 2021, which is year 2021. Happy New Year, and I really hope that this year will be the best year for the whole globe, not just us. Okay, so everywhere, all over the world. Okay, so that's 100, yeah, yes, 2021. Okay, so here I really didn't want to go with the previous example, which was 2020. So the year really wasn't a good one. So we are all hoping for the best one. Okay, so here, yes. Now I talk about simplifying expressions here. So I talked about simplification. I just said simplification is very important because it's important for algebra. It's important for solving equations. It's very important for that. So I want to talk about it, how to simplify. Okay, so maybe I give you just 10 seconds to just read through this paragraph, because it's very important. Okay, so, and I just I will explain after. Okay. As you read here, when you simplify, you have to collect all the like terms. Okay? You have to collect all the like terms. So what do I mean here? Collect all the like terms. Okay, if you were here and I could ask you, I could just ask one of the students to tell me. Right now, no, I have to answer myself. So when I say I want to collect like terms, I have to look at the variables beside the coefficients and to the power. They should be the same variable to the same power. For example, x, y and x squared, y squared, although they have the same variable, they are not like terms because one of them is x squared, one of them is just power 1. When I say like terms, means I should have a x, y, for example, power b power c, d x power b y power c. Okay, so I have the same thing here, I have the same thing here, and I just have different coefficients. Means I have apple and apple. For example, I have 5 apples and 10 apples and I want to add them or I want to subtract them. Okay? If you want to be very good in solving equation, you have to be very good in simplification for simplifying in algebraic expression. You have to really be good in them. Okay? So, you have to look for like terms and collect them in order to reduce your work, in order to make it simplified. If you make mistake here, whatever you do in solving, it will be wrong. Doesn't matter. Okay? So, how do you do that? In addition and subtraction, how do you do that? When you want to simplify. Okay. Even me, when I start to do a simplification, okay, for just algebraic expressions, so I always group them, or I would say underline them, okay, make symbols. What do I mean here? Okay, here, if I don't do that, I make mistake. Even me, I miss one of them. See, I say, okay, the first one is x. I just continue to the end to find all x and underline it. The same color, the same number of lines under it, the same symbol. Then I'm done with x. I go to y and I do that. When I am done with all of them, I collect them. Oh, okay, so 2x minus 4x is minus 2x. 3y plus 2y is 5y. And then I am done. How do I do that? I say this, okay, 2x and minus 4x, I cross them. 3y and 2y, I cross them. Oh, perfect. So I collected them. Okay? Yes? So far so good? Okay, so again, here, if I have something like that, I have addition, I have subtraction, I just see, oh, okay, I have the same variable to the same power. So now I can add these two or I can subtract these two. Depends on the sign I see. So when I have the same variable to the same power, that's like terms. Okay? How about here? How about in this practice? Oh, okay. The first one is AB, the second one AB. Oh, AB, all of them AB. Oh, okay. So, I have 23.9 plus 54.9 minus 65.1 multiple AB. Oh, good. Which is 13.7 AB. If I don't say these numbers are approximate, you stop here. But if I say these numbers are approximate. In this case, you round appropriately, which you learned last semester. Oh, appropriately. When I'm doing addition, subtraction, round appropriately means I have to round to the least decimal place. So 1 decimal place, 1 decimal place, 1 decimal place. I have to round to 1 decimal place. Oh, okay. So I underline that. I don't say anything after. So yes, it is this number. Because I need 1 decimal place. That's the answer. So far so good? In this case, it didn't change. But if we say approximate numbers, yes, we have to think about rounding. That's the answer. Okay, so how about next one? Oh, okay, how about next one? Okay, so I start from the beginning. I start from the first term. What is the variable? X. Okay, I continue to find all X. I'm done. Now Z. I continue to find all Z. Yes, I'm done. I continue to find A. Oh, yes, I'm done. Okay? Perfect. So now I have 1.95 minus 9.27 X plus minus 4.38 minus 5.21 Z plus 2.83A. Yes? Yeah. Like terms. Okay, I told you. Whenever I do that, I cross them. If I don't cross them, maybe I miss them. Okay, so I do that. Then I do this. And then I do this. Yes. Okay, now I find the answer. Here is minus 7.32 X minus 9.59 Z. Okay, my handwriting, so maybe I have to do Z here, like that, and 2.83A. The reason I didn't round, because I have, for example, 2 decimal place in both of them, 2 decimal place. So I have to round to 2 decimal place, okay? And if I don't say approximate, you don't need to think about rounding. No. If I say approximate, yes. Okay. I go here. Now I go to this example. This example is different. Why? Oh, because I have group. First, I have to remove the brackets. Oh, okay, I see. My recommendation, if you can simplify inside each bracket. Okay, the first bracket I cannot simplify. Why? Because I don't have any like terms. I don't have any like each other. Okay. Inside the second, again, no. For the next one, I just have to be careful. See, I have minus here. This is where I see a student make mistake. When you have minus, you have to multiply minus before the bracket. You have to multiply minus with all of them. Oh, okay. So you have to change sign of all of them. So plus 3p minus r plus 10s. How about the other one? Yes. So it's plus, maybe I change the color. It's plus 5b minus 2p plus 2r minus 4s. Okay? Oh, yes. So again, my recommendation, if you can simplify inside each parenthesis or bracket or do it, or braces, do it. Okay, for each group. Here I can't. Here I have B, P, R, S in one of them, P, R, S in one of them, P, R, S in one of them, B, P, R in one of them, so I can't, okay? Now I start from the beginning. Okay, 3B, P, R, S, P, R, P, R, S, B. I'm done. Now I go to P, and here, and here. How about R? R, and R, and R, and R. How about S, and S, and S? Okay? So now, let's collect them. Look at this. Look at this long algebraic expression. When you look at it, you see, oh, okay, I group all of them. Oh, I didn't miss any of them. So, grouping is important. Okay, so removing bracket is important. Grouping is important. Simplification of each bracket, if I can, is important. Now I group them all. Okay, so now I collect them. 3B and 5B is 8B. Minus 7P and minus 2P and minus 11P is minus 19P. Yes? Or minus, let me see, minus 20P. Yes? Okay, just 1 second. Okay, let me see. Do I have... oh, yes, I have another P here. Okay, yes, I missed that. Okay, so minus 7P, minus 11P is minus 18P, then minus 15P, minus 17P. Yes, minus 17. See, if I don't just cross them, I just miss, okay? So then I go to this one. Then I go to R. Okay, so 4R minus R is 3R, and 2R is 5R. Okay, 5R and minus 19R is minus 14R. Oh, okay. Then I go to S. Okay, I go to S. I change the color. I change the color to this. Okay, 3S plus 10S is 13S plus 9. So minus 4S, which is 9S. Okay, so 9S. 8B minus 17P minus 14R plus 9S. What I did must be done always, not even when you are very good in math. Doesn't matter. If you don't do that, you miss one of them. So remove the parentheses, simplify parentheses before removing if you can, and then make symbols under them. When you see all of them have symbols, start to collect them. When you are collecting, cross them, because at the end you can say, oh, I crossed all of them. Oh yes, I didn't miss any of them. Okay, how about this one here? Oh, okay, so this one here, minus A plus 5X plus A cube plus 3A minus 11X squared plus 2A squared minus 3. Okay, so far so good, but here I have to change. So minus 7A squared minus 3A cubed plus 6X squared minus 12. Yes. Why? Because I have minus, I have to change all of them sign. I have to change all of the term sign. Okay, so far so good. Now I collect them. This is A, not 9. My handwriting awful, I know. Okay, so this one and this one together. This one. Done. This one. No, this one and this one together, right? Then I have this one, x squared, done. Then I have this one, which is a squared. Then I have this one and this one, yes. And then I have this one, x cubed. Okay, oh, so many. Okay, so minus a and 3a, so it is 2a. Now I change. Okay, the other one, just two lines, 5x, done. A power 3 and minus, okay, so this one and this one is minus 2a cubed. Minus 11x squared. Yes, so I cross that. This one and this one I cross, so it's minus 5a squared. So again I go back to, because I need another color, so it doesn't matter, I can go to blue again. So minus 3, and so this is minus 15. So I cross them. I cross this way because then I don't mix them. Okay, so the next one is, so maybe instead of that I can do this, and then you can see they are different with 2a. The next one is plus 6x cubed. Okay, so I can do this. Yes. Okay, so at the end I have 2a plus 5x minus 2a cubed minus 11x squared minus 5a squared minus 15 plus 6x squared. Yes, I know some of them a and a squared and a cubed, and x and x squared and x cubed, another number, but they are not like each other. X and x squared and x cubed are not like term. I want to emphasize. Now I can go to exponent laws. Yes, exponent laws, you know them, but I just wanted to bring them here just to refresh your mind. If I have x power 1, that's x. If I have any number power 0 is 1, except infinity. I say infinity because of course you don't see infinity power 0 here, but if you go to university, engineering or bachelor, just to have calculus there, you will see something like that, and that infinity to power 0, it goes to limit, so it doesn't stay with just like here, which says, okay, I say infinity power 0 is 1. No, it doesn't work, okay, because infinity is not really clear. Okay, I just want to emphasize here, because I know based on your background some of you have these things in your mind, and I want to emphasize just to refresh your mind. Okay, if you have any number except infinity, power 0 is 1. Any number power negative, I can change it to the denominator and change the power to positive, from top to bottom, bottom to top. Remember, the only thing I am moving the number with negative exponent, that's it. Okay, so if I have multiplication, I add exponents. If I have division, I subtract exponent. If I have multiple, I multiple exponent. Sorry, if I have power, I multiple exponent. Okay, so these are just added here because I wanted to refresh your mind. So here, for example, when you have x, for example, power 1 over 2, that means radical x, because 2 goes here and 1 go here. When 2 is here, I don't show it. Okay, so that's just radical x. So if I have fractional exponent, it goes to roots. The denominator is root and the numerator is power. Yes, you can see. Okay, so now I am going to do just some examples. So I really didn't want to do without just saying that these are these are the rules. Okay, so you can go back to the for example to the lesson and see, and you have access to the lesson. Okay, so to see what is these rules here. Okay, now I continue on this one. So here, this is example here. Okay, so I can say these numbers are approximate. Okay, so we can say that. If I don't, you don't need to think about rounding. Okay, you don't need to be worried about rounding. But if I say approximate, yes, we think about rounding. Okay, so here I have these two terms and I want to multiply. Remember, if I have a x power b y power c multiple d x power e y power f, I multiply this with this, this with this, this with this. So it is a d x power b plus e y power c plus f. Okay, so here it is minus 6.72 times 5.27 a power 1 plus 2 b power 4 plus 1 c just power 1. Okay, so how can I round here? Okay, so I can round here this way. So this is 3 significant digit, this is 3 significant digit, I round to 3 significant digit. Why? Because it's multiplication. Multiplication and division, I round to the least significant digit. So if you are my student, I want you to show me rounding this way. I want to see the question and I want to see that you say, okay, how you are rounding, which is this part. And I want you to show me the number, the answer, which is minus 35.41. Okay, because I want 3 significant digits, so I just show 4 significant digit. Okay, this is the answer. I don't need to show more significant digit. I don't need. Okay, and then I underline that the third significant digit, I check the next one, and it is almost minus 35.4. Okay, so maybe I change the color so that's easier to see. Minus 3.35.4. Okay, a power, so that's for that part. A power a cubed, b power 5, and c power 1. Just c. So the first step of rounding is the yellow one here. So this one as well. The number before rounding as well, and the number after rounding. Remember, you have to show all of them. Because maybe in future you are working for someone in a company, or your future teacher for another course, they tell you, okay, I know you rounded to minus 35.4, but what was the number before rounding? And you cannot say, I don't know. So you have to know the answer before rounding, you have to know the answer after rounding, and you have to know how to round it, how you round it. You have to know all of them. So right now you don't do on the paper because it's online. But if you do on the paper, you have to show me this. You have to show me this, you have to show me this, and you have to show me this. That's the answer. Okay? So now I continue here. Okay, so quotient. Quotient doesn't mean division. Quotient is the result of division. So if I say what is quotient of 6 and 2 means 6 divided by 2, which is 3. Quotient is the answer of the division. Okay? So here. But it comes with division. Okay, so we are dividing. So again, if I do a x power b c power y power c divided by d x power e y power f, it's this divided by this divided by this divided by this. which is a divided by d, x power b minus e, y power c minus f. Okay? So, here, minus 12 divided by 4. So, m, 2 minus 1, n, 3 minus 2, which is minus 3 m, n. Yes? Number with number, m with m, and n with n in division. One of them positive, one of them negative. Yes, the answer is negative. Yes? Good. So now power. When I have power, so it means I just do, okay, so let me show you here. A x power b y power c power d, for example. So it's a power d x power b power d y power c power d, which is a power d x power b d y power c d. Okay? So, I multiply powers when I have power on power. Oh, okay. So, here, it's not 4 multiple 4, no. It's 4 power 4, x power 5 power 4, y power minus 2 power 4, which is 2, 5, 6, x power 20, y power minus 8, which is, okay, that's a good question. I want to see with positive exponent. What should I do? Do I touch 2 5, 6? No. Do I touch x power 20? No. Okay, so 2, 5, 6 stays up. If the number is positive, it stays positive. Negative, it stays negative. Up, up, down, down. I don't touch it. Okay, so what do I touch then? The only thing I move is the term with, is the variable with the negative exponent. Oh, okay, so x power 20 up, but y power 8. Okay? Maybe here I want to emphasize, because sometimes I see a student, they say, for example, they say, minus 4 is 1 over 4. No, it's not. How about if I have 4 power minus 1? 4 power minus 1 is minus 4? No. 4 power minus 1 is 1 over 4. The one with negative exponent from up to down, down to up, and you change the power. That's it. Okay? How about power 0? Yes, I said power 0. If you have any number power 0, anything power 0, you don't need even to simplify. Just say 1. The answer is 1. But remember, infinity power 0, you don't see it in the college, but if you go to calculus university, you see infinity power 0. That's different. That goes to limit. That's a different concept. Okay, so this is 1 here. I don't need to even simplify inside. How about negative exponent? Oh, negative exponent. Okay. For negative exponent, let me give you a hint. If you have negative exponent, for example, a power minus b, okay? My recommendation, my suggestion is flip it and change the power to positive. Oh, okay. So it's 1 over a power b. And then go further. And then continue. That's my recommendation. So flip inside and then change the power to positive. And then continue. This is one method. But if you want, you can do, so I can show you both methods, okay? So let me show you both of them. You can choose whatever is easy for you. Okay, so here I flip first. Remember, I flip with no change. Just flip it and change it to positive power. No change. I just flip. Whatever up goes down, whatever down goes up. That's it. Okay, so it is that here. Okay, so now you continue from here. Oh, okay, so minus 1 over 3, oops, minus 1 over 3 power 3, okay, 1 over w power 3, okay, so 1 over x power minus 6, because minus 2 power 3, multiple 1 over y power 12, okay, because it's 3 multiple 4. So it is minus 1 over 27 x power 6 over w power 3 y power 12. So first I flip. Whatever I see up comes down, whatever I see down comes up. No change, just I change power 3 to minus 3 to 3, negative to positive, and then I go continue after. For each power I need to multiply. Power I multiply, and then I move whatever with negative. That's one method. Another method here, I can do minus 3 power minus 3, w power minus 3, x power minus 2 minus 3, and y power 4 minus power minus 3. Okay, so equal. Okay, so this one is minus 1 over 3, so for that power 3, 1 over w power 3, x power 6, and y power minus 12, which is minus 1 over 27 x power 6, w power 3, y power 12. So whatever is easy for you. You can do the power, which is the right one. You can use the negative power for each of them and then go continue and then continue after, or you can flip from the beginning, change the power to positive and then continue after, which is the left one. Depends on you. But remember, if you go with the left one, you don't do any changes. Just flip it. Maybe I can write it here. Okay, so a power, for example, minus 1 is, I flip 1 over a power positive 1. A over b power, for example minus 2. Okay, so it is b over a power 2. That's easy for me, easier for me. Okay, so it's easier for me. I don't need to say here a power minus 2 divided by b power minus 2, and then I say okay, b power 2 and a power 2. See, it's more work, so I flip it and change the power to positive. Okay, so that's easier for me. So again, the left method is easier for me, but doesn't matter. If you want to go with the right one, you can. Okay, so now I stop here for the second video number 2, and then I continue after. Thank you so much.